Hi everyone, this is Hossein from EJ Academy, and today we're going to solve another calculus problem. Amir is here. Hi Amir, how are you
Hello,
today?
Hussein. I'm good. How are you?
I'm good, thanks.
Mhm.
So Amir, thank you for joining me. So I have a calculus problem for you.
Mhm.
This is a problem that you're going to use limit in calculus to solve this problem. So this is one of the applications of limit. So we're going to use limit to study the behavior of this function that you can see on the screen. The function is f of x equal e to the x minus c times x. C is a constant parameter and x is the variable. So we wanted to see what is the behavior of this function
Mhm.
as x approaches positive and negative infinity, and at the same time when c varies from like positive value to negative values. And feel free to use graphing calculator like Desmos to
Yeah,
study the behavior of this function. This
sure.
problem has another part, which, after you went through the first part, I'm going to read the second part for you.
Sure, thank you. And as I understand, C is a real number, can be a positive or negative
Mhm.
value.
Right.
Uh, okay, uh, sure. So let me just write it here. C is a real number.
Mhm.
Uh, okay, I'm gonna use Desmos as you mentioned, which is
Okay.
a powerful application.
Yeah, it's very
Uh,
cool tool.
yeah. So let me uh, in here, let me use the keyboard here. So it was
E to the x
e to the power of x
minus c times
minus
x.
c
Letter c times x.
times x.
Mhm.
Okay, I add a slider here for
Yeah,
c.
that's one of the cool features.
Yeah, we can do parametric study.
Mhm.
Uh, so yeah, when c is 1,
Mhm.
we can see here that uh,
So the question is,
mhm.
what is the limit of this function as x approaches positive or negative infinity?
Yeah, as you can see, whenever when x approaches to the left, which is
Mhm.
towards negative infinity, or to the right
Mhm.
towards positive
Mhm.
infinity, we have a positive infinity.
That's correct.
Yeah,
How
because
about
it's
for
close.
like other values of c?
Yeah, let me see that. Uh, let me go less than 1. Okay, as I decrease value of c,
Mhm.
we can see that. Let me zoom in again. Yeah, we can see that, for example, for 0.5,
Mhm.
again, we have, positive infinity for the left and
Right
right.
branch. Right.
Right. It's
The
like,
rate is
the
different.
wings. Yeah.
Right.
Yeah. The rate is
So
different, but
yeah.
in the limit sense, it approaches to positive infinity because it's upward,
Yeah.
it is facing upward,
Yeah.
the curve. So, and when c is 0, that
Mhm.
makes sense because it's going to be e to the
To
power
the
of
x.
x.
Mhm.
Yeah. Uh,
So in
so,
that is in that special case, when c is 0, so it's going to be e to the x, and we already know that the limit when it goes to negative infinity
uh,
is going to be 0, right?
yes, yeah. So uh, that's just for c
Equals 0.
equal to 0 and greater than is. Let me just summarize that. Let me
Okay.
uh, go back to GoodNotes. Uh, so if c is greater than 0, limit of f of x when x approaches to positive, negative infinity is positive infinity, correct?
Right.
If c is equal to 0, then we have two cases. One, limit of f of x when x approaches to positive infinity, it is positive infinity. And when x approaches to negative infinity, it is 0, correct?
Right.
Yeah, but that makes sense because we just have e to the power of x, and when it is negative, it is, like e to the power of x, and when this is a big number in the denominator, we have 0.
Right.
So yeah, that makes sense. So this is, I call it A, B. Okay, that's for C positive or C equal to 0.
0. How about
Negative C, yeah?
yeah.
If I just go a little less than 0, as you can see, for the right side, it's still positive infinity, but for the left side, it is negative infinity.
That's
And
correct.
if I increase the value of C, as you can see,
this is still negative infinity.
Yeah.
But the rate
left
is
side,
increased. Yeah.
The rate is increased. The right side is almost the same.
Right.
So, okay. So case C, if C is negative, then limit of f of x. Still, we have two cases. Let me write like that. One, limit of f of x, x approaches to positive infinity is positive infinity, and negative infinity, it is negative infinity.
Okay, awesome. Yeah. Yeah,
So,
thank you.
Sure, yeah, I think that answers
yeah, you answered the first part.
Yeah.
So let me read the second part for you. So the second part of the question is asking what happened to the minimum of this function as c increases. So if you go back to Desmos, the function has a minimum point, and then that minimum, it changes when you use the slider to change the c value.
Yes.
The minimum change. So if you can show us in the Desmos, what's the behavior of that point when c changes?
Yes, yeah, and here it says that determine the values of C for which F has an absolute minimum. So it was for C greater than 0, positive C.
Right.
So for and F has absolute minimum. Yes.
So in this case, when c is negative,
We
can
don't
you go
have
to
any.
the negative? Okay, yeah. Go ahead.
Yeah, it is negative. We don't have any absolute value, absolute minimum.
Right.
Yeah.
Yeah.
When it is 0, the absolute, I mean, in the limit sense, it is 0, the absolute
but you're not going to reach that.
Yes, yeah, we don't talk about the limit here. But when once it is greater than 0,
right,
then we have absolute minimum, which is this point here.
Right.
0.33.
Right.
absolute minimum, for example, and if I increase the value of C,
maybe you want to zoom in a little bit
yeah,
toward
sure.
toward the minimum point. Okay.
Yes, yeah. So here is the value,
okay.
0.9.
Mm-hmm.
Okay. At 1,
Mm-hmm.
it is 1. And when C is greater than 1,
Mm-hmm.
suddenly, it slides down.
Right.
Fun.
Yeah, that's so cool. So
Yeah.
the minimum point decreases when you increase the C.
Yes. So as you can see, as I
Yeah,
increase
for the
C,
value of C greater than 1.
yeah,
And then how about between 0 and 1?
it increases, because for
Okay.
example here,
Mm-hmm.
0.3.
Right.
Okay.
Mm-hmm.
I just a little increase the C value.
It went up.
Yeah.
Mm-hmm.
0.76.
So when C is between
0 and 1,
0 and 1, when you increase the C, the minimum
the
goes up.
minimum goes up a little,
Right.
not too much,
Right.
At 0.1,
Mm-hmm.
it is 1.
Mm-hmm. When C is equal to 1.
Yeah. And when it is greater than 1, it again, decreases.
Mm-hmm.
You see?
Yeah.
And then if you increase more and more, it goes down, with
Right.
higher rate.
Mm-hmm.
So yeah.
Okay. Yeah, that answered the second part of the question.
Yeah.
Maybe you wanted to summarize that for the viewers
Sure.
at the
Yeah,
note.
absolutely. Let me call it part D.
Mm-hmm.
So what happens to the minimum points as C increases? So, okay, if C is between 0 and 1,
Mm-hmm.
there is absolute minimum, and the absolute minimum
Right.
increases as C goes up.
Right.
But if C is greater than 1,
Mm-hmm.
absolute minimum
Mm-hmm.
decreases.
That's correct.
Decreases as C
Goes up.
goes up. Yeah.
Yeah, goes up.
So that's what we observed
Yeah.
in the Desmos
Right.
application.
Yeah, that's cool. Yeah, thank you, Amir. So to summarize what Amir did here in this video, he used a graphing calculator to show us how the behavior of this function, how this function is behave when the constant parameter C is changing. And he looked at the limits of this function as x approaches positive or negative infinity, and also he looked at the behavior of the minimum point of this function when C changes.
Absolute minimum, correct.
Yeah. Yeah. All right. Thanks, Amir. Really appreciate it.
Sure.
And for the viewers, thanks for watching this video. If this video was helpful, please hit the like button. And if you are interested to get notified whenever we upload a new video, please hit the notification bell below this video. And till next video, bye everyone.
Thank you. Bye, Hossein.
Bye.